Okay, Math 098, we're doing Chapter 5, Section 1, and we're going to be messing with exponents in scientific notation. So to start this off, I like to just explain this a lot longer than just saying what the rule is and then having you memorize it. Because what this really means is 3 to the 4th power means it's 3 times 3 times 3 times 3. And then 3 squared really means 3 times 3. And there's a times in between, so we can actually just drop all of those parentheses, and we have 3 times 3 times 3 times 3 times 3 times 3, so that is 3 to the 6th power. And I can do every problem this way if I wanted to. And you're probably thinking back to Algebra 2 and how you just memorized that you have 7 x's there, and what you're really doing is adding the exponents. So now I can actually explain that rule. What's the product rule? Let me change colors real quick, except my thing's in the way. I don't know, now I can change the colors. X to the m times x to the n is equal to x to the m plus n. And the book might write it a little bit differently, but that's the main premise here. The only other thing to add to this is don't forget that if you have just a variable, then it's implied to be to the 1st power. And let's say you have another, you just keep adding. 1 plus 3 is 4 plus 5 is y to the 9th power. If you're not quite getting that, feel free to write it all out just like I did here or here, but otherwise you can just add your exponents. So continuing with that product rule, sometimes I even write it this way, that you multiply your coefficients and then you add your exponents. And some teachers actually make you go through and they rewrite this as 5 and they let you practice the associative property, and then they have you practice the commutative property. I wasn't supposed to put a parenthesis there yet. Whoops, hit the wrong button. Trying to get rid of that. There we go. Times z to the 3rd times z, and then practice the associative property again. So then you can actually see that 5 times 7 is 35, and when you add your exponents, that becomes z to the 4th. Okay, I do not anticipate us doing that. Looking at the next one, again, make sure you're only adding the exponents with the same variable. Okay, but 5 times negative 4 is negative 20. 0.1 times 5 is 0.5. So it becomes t to the 6th power. Try to put a little hook on my t so it doesn't look like a plus sign. Because this exponent's 5, this exponent's 1. 5 plus 1 is 6. And then q to the 8th power. This exponent's 3, this exponent's 5, 3 plus 5 is 8. There's that answer. All right, let's talk about a new rule, which is any base to the 0 power is equal to 1, with the exception that the base cannot equal 0, because 0 to the 0 power is technically undefined. The best way I can explain this is thinking about let's just come up with a number. Let's say the base is 3, so just some scratch work. Like 3 squared is 9. I can do 3 cubed as well as 27. Well, there's a pattern going on as we go to increasing exponents, and that pattern is multiplying by the base, so multiply by 3. In other words, if you're going backwards, you need to divide by 3. That's supposed to be a division sign. Divide by 3. So that means if I do 3 to the 0 power, I need to take the previous base, or value, I guess, and divide by 3 to get 1. And that's what will happen for every one of them. That's why when you get to negative powers, you get to fractions, which we'll get to in a second. So anyway, the moral of that is that 5 to the 0 power is equal to 1. Okay, but then I threw in a little trick to you with the next one, because in the order of operations you do the exponent first. So 5 to the 0 power is 1, and then that negative in front stays there. A big difference than if I put it in parentheses. So all of this is in parentheses. To the 0 power is equal to 1. It doesn't matter what x is. I guess I should have the value that x cannot be 8/3, because then it'd be 0 to the 0 power. So let me write that down. Assuming x does not equal 8/3. Because if x were 8/3, then we would have 0 to the 0 power, which is undefined. And then one last problem here. I'm trying to change colors. Remember, you do x to the 0 power first. So 3 times 1 gives you an answer of 3. I know it's not written here, but what if I wrote it this way? 3x to the 0 power. Well, it's the 3 is to the 0 power and x is to the 0 power. So that answer is just 1. So they're both going to be to the 0 power. So keep those problems in mind as we move forward. So again, I warned you that we were going to get to tougher problems. You might be looking at this and saying, oh, that's not too bad. And again, my division signs don't really show up well on these problems, so I'm going to go ahead and add those in. Alright, so you can do this a long way, kind of like what I was explaining earlier, that you could rewrite this as z 8 times. And you can write the z in the denominator 3 times. And as you're looking at that, I think you can see if you have the same thing on top and bottom, they'll cancel each other out. Z divided by z is 1. Z divided by z is 1. Z divided by z is 1. So you're just left with 5z's in the numerator. And you don't have to write over 1. There's no reason to do that. Well, you probably remember from Algebra 2 that the rule is to subtract your exponents as long as the base is the same. So this answer right here will be 3 to the 6 power. Okay. By the way, I will accept it if you give me the numerical value, but I care more about you understanding these rules opposed to just plugging into your calculator. I will accept it though, because the directions are pretty unclear. So let's give you a written out rule. Remember when we multiplied the coefficients? Well, now when we divide the coefficients and we subtract the exponents. So as I look at letter C, 45 divided by 5 is 9. 7 minus 4, because they're exponents, 7 minus 3 is 4. I said that wrong. I knew the answer was going to be 9x to the 4th though. Now I need to be careful about how I say divide my coefficients, because sometimes I just want you to reduce, and that's what's happening in letter D. 24 over 18 reduces because they're both divisible by 6. Dividing by 6 to give me 4/3. And then subtracting the exponents with a, 14 minus 7 is 7. Now here's the thing is 6 minus 6 is 0. Now you could write it down, but that's not your final answer. And the reason for that, as we established in exercise 3, is b to the 0 power equals 1. And the rule for simplification, let me write this out. When you're trying to simplify, you continue on until all the things are reduced and you only have positive exponents. That means 0 as an exponent does not work. It's not allowed. And I think you're probably getting that. As you look at the next exercise, you probably remember, and I sort of explained it, is if you have a negative power, we stick that into the denominator, so 1 over 6 squared. And as I mentioned earlier, I'm interested in seeing this as your answer, I'm well aware that some of you might rewrite that as 1 over 36. Okay, I do not want to see decimals though. I'm okay with a fraction, but I do not want to see decimals. So same thing with letter B. This is 1 over negative 2 to the 6th power. So when you have a negative exponent, it's becoming a positive. Now the reason why this final answer becomes a positive is if you have an even number of negatives, like we have here, you're going to end up with a positive. So I'll accept it if you just rewrite it as 1 over 2 to the 6. Or if you actually figure out 2, 4, 8, 16, 32, 64. I'm doing that in my head, so you might get a slightly different answer. I hope I did that right in my head is what I'm saying. Remember the order of operations. You only do, you do the parentheses first. So because there's no parentheses, you do the exponent next. So only x to the negative 5th gets moved into the denominator. Because the 3 did not have a negative exponent, it's like 3 to the 1st, that stays in the numerator. It's very easy to do. It's also very easy to mess up. You see how everything in letter D is in parentheses? So each piece is taken to the negative 1st power. 5 is taken to the negative 1st. Y is taken to the negative 1st. So the answer I'm looking for there is 1 over 5y. Right. If you're having any questions, please feel free to write them down and answer them in class during a Google Meet, something like that. What I like about all these exponent rules is they still work. Okay, for instance, we're dividing, so you subtract with your exponents. Well, 4 minus 11 gives me negative 7. Well, remember earlier I said we never want to leave our answer with a negative exponent. So it's equal to 1 over k to the 7th power. And again, you probably remember from Algebra 2, your teacher saying, well, pick the larger number, 11's larger than 4, and you do 11 minus 4, and because 11's in the denominator, your answer stays in the denominator. That's exactly right. So you can do the same thing here. Which number is larger? This 5 is what I'm talking about, is larger than this 3. So your answer is going to be 1 over 5. It's a larger number, staying in the denominator. And what's 5 minus 3? 2. Again, this is how I want to see the answer. I'll accept if you rewrite it as 1 over 25. I think the last problem, I know there's 2 more. We're going to rewrite this as just 1 over 5 plus 1 over 2 squared, so 1 over 2 squared would be 1 over 4. I think the book wants you to simplify this, where you get the same denominators. Well, 5 to be a denominator of 20, you have to multiply by 4. And 4 to get a denominator of 20, you have to multiply by 5. 1 times 5 is 5. So, at some point, though, I imagine some of you will rely on your calculator, so I will accept this answer as well. At least you're showing me that you understand. All right, and then the last problem I'm going to do in this video is, what if you have a negative in the denominator? The quick way of explaining it is you just move it into the numerator and it becomes positive. So it's just z to the 8th power. The real reason why that happens is it's 1 over z to the 8th. And when you divide by a fraction, it's the same thing as multiplying by the reciprocal. Well, 1 times z to the 8th divided by 1 just gives you z to the 8th. All right, so I'm out of time. I will come back and finish these notes. I will come back and finish these notes in a second video.